Hi guys, today we'll be covering tabular integration, which is just a little bit fancier integration by parts. So to go over what tabular integration really is, we'll go through an example problem, we'll go through integration by parts, and then I'll show you how it's related to this different method of going about integrating. So let's get started. So what we know from integration by parts is that we basically split this interval. We have a u and we have a dv. And so in this case, since we want to be integrating something that's going to be easy, we'll integrate e to the x dx. So dv is going to be our e to the x dx, and then u is going to be our x cubed. So through integration by parts, we'll have u is equal to x cubed, du is equal to 3x squared dx. dv is equal, that should be a v, is equal to e to the x dx. V is equal to e to the x. So when I plug this back in, we have uv. I always remember that through UV radiation. I just found that funny. Minus our v du. So we're at 3x squared e to the x dx. So now we have to do another integration by parts. So keeping the same thing that we did here, keeping in mind we want to make it easier on ourselves to integrate, less mistakes, etc. So we're going to treat it the same thing. So u is equal to 3x squared, du is equal to 6x dx, dv is equal to e to the x dx, v is equal to e to the x. Okay, now let's plug it all in. X cubed e to the x minus parentheses uv minus our integral of v du, 6x e to the x dx. Close integral. I'm just going to close the parentheses. I'll get rid of the parentheses and put a plus right here. Okay, so we see it one more time here, and we see that every time we do take an integration by parts, this power right here on the x is going to go down. So effectively, this would be our last integration by parts. So when we take it, so u is equal to 6x dx, du is equal to 6 dx, dv is equal to e to the x dx, v is equal to e to the x. When we finally plug it all in, we get carry down our terms plus uv 6x e to the x minus the integral of v du, integral 6 e to the x dx. Now this is literally just, we pull out the 6 because it's the constant, and integral of e to the x, as we established throughout this whole thing, it's just e to the x. So we could just rewrite this as 6 e to the x plus c, because it's an indefinite integral. And so that would be our answer through integration by parts. Now where tabular integration really comes in and makes it a whole lot easier to do is when we have to take multiple integration by parts. And writing this whole thing out, as we will soon see, is very descriptive at first and very good to learn when you learn how to integrate. But over time, you start picking up things a little quicker. So when you go into tabular integration, you look at this, we're like, okay. So we see an x cubed, so we know we're going to have to do x cubed and e to the x, so we know that u sub's not going to work. We can't rearrange it with algebra. So we know, and we're going to have to do integration by parts. But since it's x cubed, we know we're going to have to do multiple of them. Because each time we do integration by parts, we subsequently take a power in the x and simplify it down. So what we can do is just like, okay, so we have this integral. Let's make a table. The differentiating term, an integrating term, and I'm going to write out right here what sign that both these terms are going to have. We'll explain it later. But the sign right here is going to be alternating. So it's going to be plus, minus, and I'll explain in a minute. Differentiating term will make it easier to differentiate and integrate. So same thing as we did here. We'll have x cubed 3x squared, 6x, and 6. Integration, e to the x, e to the x, e to the x, e to the x. Okay, so what tabular integration tells us is that the solution of this integral, which I think you guys will like, is just equal to taking this like that. And that's why I put the sign out here, because it could be plus x cubed times e to the x minus 3x squared times e to the x plus 6x e to the x. So we put it all together. It's going to be oh, sorry, there should be another one right here. And that's our answer. And we can see it right here. So we could really break this down and look, okay, so which term are we going to be, and really relate these two, because look, each time we look here, we would differentiate the same term. So if you really think about it, each term that we differentiate here and here, they're all the same, right? And the same thing for the term that we always integrate. It's always going to be e to the x. And the main reason why the plus and minus comes in is because every time we do uv minus the integral, it's this minus right here that always changes, because then when you do multiple of them, it's going to be minus minus, and so the next one's going to be positive while that one stays negative. And so that's why we get the alternating sign. And as we can see, all the terms match up. And then plus c at the end. Really, this is just a fun way of integrating, and it could save you time, but I would recommend that if you're not too comfortable with integration by parts, stick with this until you feel a lot more comfortable, because it really is just a shortcut to use it. It's the same thing. You're using the same method. You're just not writing out as many terms and going through all the math. You're just making a table and just lining everything up, basically. So this is why this method can actually save you a lot of time. And it's just, honestly, it was really fun to use because you arrive at such a long answer, which it would take you, I don't know, 5 minutes to take. But like here, you just write out your terms, and you take like not a lot of time. So that's it for today. I hope you found this useful, and I hope you found this enjoyable. Thanks for watching.